Hello parents and students. In this video we're going to look at a connection between the multiplication strategies we've been working on and our division strategies. We're going to start off with the multiplication strategies just as a review. The first problem we're going to work on is 42 times 36. When students were doing this problem in class, I had the students think about it as an area problem. If we're going to break this problem apart into its place value parts, I have 42 times 36. So I'm going to take my 36, 30, plus 6 is my 36, and then I have my 40 plus 2. If I was working for a carpet company and I had to figure out how many square feet of carpet I would need in a room this big, I would have to multiply all the parts, the length times the width, to figure it out. So we can use that thinking to solve our area problem. When I solve it using this area model, and we're going to use a similar area model to do division, I'm multiplying each part. 6 times 2, so that this area is 12. 6 times 40, so this area is 240 square units. This would be 30 times 2, which would be 60 square units in that section. And then this part would be 30 times 40. So I'd have 1,200. Using my basic facts, 3 times 4 is 12, but I have hundreds here, 12 hundreds, which is also 1,200. So I can use this strategy to figure out the total area of this space. When students go into junior high, they're going to have problems like this, but instead of having this number, they're going to have a variable. So by having the students use this sort of a model in multiplication when they're in grade school, it sets the foundation for later work with algebra. And also, the 4th grade standards ask us to use place value strategies to help the students understand multiplication and division. When students are solving a multiplication or division problem and they estimate, they're going to want to use the largest part of the number to estimate. So about how much should my answer be? It should be a little bit more than 1,200, because that's the largest part of the number that I'm multiplying. When I go through the process, when it's stacked up, I go through a similar process. 6 times 2 is 12, and I'm writing down all the products. It takes a little bit more paper, but the students can really see where the answer is coming from and how large that should be. 6 times 4, this is actually a 40. 6 times 40, so that's 240. Then I have 30. It's not a 3, it's a 30 times 2, which would be 60. And then I have 30 times 40, and that's my 1,200. And then I add my partial products together to get my total. So 1,512. When I divide, so if division and multiplication are connected, in multiplication we're putting our parts together to come up with the total. When I divide, I'm taking that number apart. So we're going to look at the problem 538 divided by 4. And I can use an area model to solve that problem, just similar to this. So in this area model, I already know what my inside space is, because when I divide, I start with that large number. We've seen it written like this also. So I'm going to show you the connection between these two strategies. I already know the inside, and I know one of my factors, and in division it's called the divisor, is 4. 4 times something is going to equal my 538. So I have to go through a couple of steps to figure out how much that answer is. So I'm going to start, I know that I have this number is more than 400, so I can take 100 times 4 to help myself get up to 538. 4 times 100 is 400. I'm going to subtract to see what I have left over. What's my remainder in this section? So I have 138 left over. And now I'm going to see, if I have 138, how many 10s are going to be in my answer. So I start counting by 4 times 1, I know is going to equal 4. So 4 times 10 is equal to 40. 4 times 2 is equal to 8. So 4 times 20 is 80. 4 times 3, I know, is equal to 12. So 4 times 30 is 120. Well, I have 138. One more, 4 times 4, I know, is 16. So 4 times 40 would be 160. That's too much. So I know I can only go up to 4 times 30. So 30 is the other part of my answer. So 130 plus a little bit more. 120, I'm going to subtract. That gives me 18 left over. And now I can figure out what's the last little piece. So I have 18 left over. Again, I go back to my counting by fours, and I can use this one. 4 times 4 is 16. And that was 4 groups of 4. So I have 2 left over, and that's my remainder of 2. So I can go back in my answer, and I can gather up all the parts of my quotient. 100 plus 30 plus 4 is 134, with the remainder of 2. And when I do the division problem with a more traditional look, I'm going to make a thinking space on the side. I'm going to do some of the same thinking. 4 times what? In the old strategy that we learned, we would just put a 1 here and put a 4 here. But when you do that, the students are not dealing with the place value that's in this number. They don't realize that this is 100. We may as adults, because we've already built that understanding in our brain, but children don't intuitively know that. So we make it really obvious by showing that that's 100. 4 times 100 would be 400. Again, just like this strategy, what are we multiplying together to get that 538? So 4 times what? Well, I know my answer is at least 100, so I'm going to go through that same process. 4 times what? So I go through my counting by fours. 4 times 30. 4 times 3 is 12, so 4 times 30 would be 120. And I know I have 18 left over. And I still have to repeat my step because I have still enough to take groups of 4 out. 4 times 4, going back to my thinking here, is 16. And if students don't know their multiplication facts, they have to make a chart. This is the best way for them to go back, because they're going to have to use that over and over again. And 2 left over. So then when I'm going to write my answer, I have to gather up all my parts of my answer, put them together. 134 with the remainder of 2. And I've also showed the students they can take this answer, double check it with multiplication. So 134 times 4, because again, I'm multiplying these two parts to get my total. 4 times 4 is 16. 4 times 30 is 120. 4 times 100 is 400. So I have 536. But I can't forget to add in my remainder. 2 more, 538. So I hope that helps you see the connection between the multiplication area model, the division area model, a more traditional division model, and then checking your answer with multiplication.